time from 6 to 6:45 in the morning. So you want me to come over then?
Yeah.
Okay. Okay. Good. 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 Take out your computers, ladies and gentlemen. And then I got a question for you. Are you happy with the idea of us starting school year in August next year or this year because of the draft?
Oh my God.
Let's see what. All right. Sophia, Angel, Lee, Ritzy, Osia, Jasmine,
Wait, when do we get out?
Our get out date doesn't change.
Why are they doing that?
Hang on. Let me finish taking attendance and then we'll talk about it. Isaiah. Okay, so before you go too crazy, seniors, you get out early either way. Now, in reality, though, all they are doing is taking the 3 days that you would have been in school in August and moving them to a week earlier in the school year. So this coming fall, instead of starting on September 1st, you're going to start on August 26th or 25th or something like that. And actually, you'll go 4 days, and they'll give you the Friday off before Labor Day. So you'll have a 4-day weekend. You normally wouldn't have started until afterwards. And then 3 of those days will be given back to you during the NFL draft. So big fans of it, raise your hand. Big fans of starting the school year a week earlier next year. What? What? Yes, you do. But then in April, you don't have to see me because you won't be here for those 3 days. So, and actually, all they actually had to do was take our spring break and put it that week of the NFL draft.
Oh my God, summer break.
Wait, so that's so dumb then. Why wouldn't they just do that anyways? Instead of
Because they thought it was a better idea to start the school year earlier.
Wait, that means we don't get spring break until April?
No, you'll have spring break when you normally do, and then about a month later, you'll have 3 days off when the NFL draft is occurring.
Just 3?
So a 5-day weekend.
Because that's all the draft is. It's just 3 days.
Oh.
Still stupid. We're gonna be so bad.
So
It's because we're gonna have an extra 200,000 people here.
I think the term is million, but I could be mistaken. Maybe
Okay,
it's
not 200 million, but
not 200 million, but 2 million.
yeah, something like that.
Something like that. There's going to be a lot of people.
We're not gonna have enough busing, and it's just gonna be a whole situation.
But if you're also a spring sport athlete, just because we are changing our calendar doesn't mean that.
We're probably still gonna
You're going to still probably have a track meet or a soccer or softball game during that time because nobody else in the area is changing their schedule. So just a point of overreaction in my opinion. What? No, I understand why they're doing it. They're saying that for your safety, they don't want to be busing people around the city on the days of the draft because there are going to be so many more people around because of it. There's other ways they could have done it.
And they could use all the people working for the draft. Yes, that's what we were talking about.
Yeah, don't plan on going out. Don't plan on going out to eat on April 25th.
Everyone's job is gonna be so good.
Okay, ladies and gentlemen, we have. Hey, focus. We have a little bit of material to get through today to cover the last of the things that will be on your test on Friday. Again, those of you who are going on the band field trip or those of you who are going to be gone Friday for whatever reason, you can take your test tomorrow if you know you are going to be gone. If you are gone on Friday and you do not take your test early, when we come back after spring break, you will have a whole extra week compared to everybody else to prepare for it. So you will take it on that Monday when we get back after spring break, just so that you are aware. Are there any questions on that?
Are we learning anything new tomorrow?
Are we learning anything new tomorrow? No. Tomorrow I'm going to basically have practice problems for you guys to work on. So if you're taking the test early, you're not missing out on anything other than practice time. So I'm not going, if I hadn't been able to get through all the material today, we wouldn't have done the early part for you. But since we will get through it all today, we are doing that. Okay? So you're not missing out on any new information. There won't be anything else on the test that is not on there. Again, if you want a study guide for the test, ladies and gentlemen, here is where it is at. It is called slide 2 in your notes. There's your study guide. That is the stuff that the test is going to be on. You are going to be asked about ionic compounds in water. You actually will not have to do an ionic equation, so that's good. You'll be asked to find a percent composition. You'll be asked to find an empirical formula. You will be asked to find a molecular formula. You will be asked to convert between formula mass and moles, formula mass and volume, formula mass and particles, or any of those others in a different order. So particles to mass, particles to volume, things like that. That is everything that we have covered this year.
Is there any SCP?
Of course there are, because otherwise I can't have you use volume.
Wait, so everything except for the last?
Except for ionic equations, yes.
So basically we don't have to pay attention to it.
Well, you don't, but it's going to hurt you for later on for Unit 7 when we're talking about those ionic equations again. So you don't have to pay attention to me any day. If you can get away without paying attention to me, heck, your life should be a lot easier and a lot better. Yes?
Do you have an extra package just because I already did everything?
Do I have an extra package? Not of anything other than what you've done.
Packet. The practice package.
I do, but it's the same one I would have given you before.
I know, but I've already done all of it and I want more practice.
Well,
but I won't have
okay, just so that we understand. That's fine. I have more packets. Yes. I thought you were asking me for more different problems. If that were the case, no, I don't. Until tomorrow when I have a bunch of them for you. You're welcome. Okay. Any other questions, ladies and gentlemen?
So then are we able to, like, the people who are leaving tomorrow, are we able to take it during class? Because you guys are
Yeah.
Okay.
Yes. Come to class tomorrow. If you're leaving, just let me know. We will put you probably in Mr. Hart's room right next door so it's quieter for you. You'll take the test, and then you don't have to worry about anything when you get back. Okay? Other than Unit 6, which will be starting then. Okay? So we'll go right into gas laws. Questions? So, Cynthia, since you're such a big fan of STP, last chance of having a problem at STP is on this test, because the next unit is all about gas laws and we won't be at STP anymore. So, okay, I'm glad you're excited about it. That's wonderful to see. Okay, ladies and gentlemen, let's talk about ionic compounds in water. Now, actually, we have already talked about this, and you have done a lab about this, ladies and gentlemen. When? Your final exam last trimester. Remember at the end when we were looking for precipitates from reactions, ladies and gentlemen? That is what we are talking about right now. So, ladies and gentlemen, it is important that we understand what happens to an ionic compound in water. Only ionic. Molecular compounds will not do this. Okay? Yes. Will this be on the test? Yes. Yes. Okay? So, if it is a molecular compound, if it is nonmetals bonded together, this will not happen. If it is a metal bonded to a nonmetal, if it is a metal bonded to a polyatomic, if it is a polyatomic that begins with ammonium, because it is a positive polyatomic ion, whether that ammonium is a single element or whether it is with another polyatomic, those are ionic compounds in water, ladies and gentlemen. So you are going to need your solubility chart out of your note or out of your sheets. So this one right here for double replacement reactions, ladies and gentlemen, you are going to need that for today. So please take that out. Okay? There are two possible outcomes determined by using the solubility of ions reference sheet. A compound could be insoluble. Insoluble means it will not dissolve. Insoluble means it will go and it will sit at the bottom of your container. Insoluble means that it will float on top. Insoluble means that it cannot be dissolved in water. This, ladies and gentlemen, right here is insoluble. The sand is sitting on the bottom. It is not dissolved in there. This is an insoluble solution, ladies and gentlemen. This, ladies and gentlemen, is a soluble solution. This has a compound dissolved inside this water. Actually, this is a special solution as well, ladies and gentlemen. This is what is called a supersaturated solution. We don't get to talk about those much in here anymore. So let's talk about it real quick. There is a salt dissolved in this water. Now, if you don't believe me, ladies and gentlemen, let me try to prove that to you.
Oh, it freezes.
And you see exactly what happened? Nothing. Not a thing. No, not a good idea. Okay? So instead, what I'm going to do is just put a little kicker in. So we are going to put just the smallest amount of stuff in there. Can we agree that's a fairly small amount? Yes.
Can you eat that?
What?
Will you eat that?
No.
You're selling.
Well, see, the problem with eating it is it would be the same as drinking it. It's still ingesting it into your system, and you probably shouldn't do that. But if we put it into here, ladies and gentlemen, this happens.
Nothing. Girl, what do you mean nothing?
I can't see.
She's blind.
She's blind.
It's freezing.
Oh,
Ew, it looks
well,
gross. I don't like
couldn't
that.
see it.
What happens if I touch it?
Does this all?
Isn't it warm?
No, it's not dissolving.
Creating
It's actually all settling out. All of the salt that was just like that is now settling out of this solution, ladies and gentlemen.
what did you mix in there?
Which means that I can then do this.
Oh.
That's
something
things
bad.
that like you just have a little metal thing on the inside and they're like pizza.
Kind of.
It's warm. No, it's not.
No.
It's not warm.
So weird.
That's room temperature.
Really?
Yes.
That's room temperature.
Yes. There's nothing there. I don't feel anything.
Yeah, something like that.
Yeah, something like that. Thank you for being so descriptive for those who didn't get the chance. Yeah, something like that. Yeah, what?
Something like that.
Yeah, something like
It's warm.
Thank you.
that. I don't know if I'm trust.
I mean, it's not hot.
No, it's because he taught
But
us to
there
touch
is
things
heat.
with the back of our hand.
I
It's not
did.
my fault.
I taught you to use the back of your hands, and if you don't feel anything, what can you do then?
Use the front and eat it.
Good. Use the front of your hand.
Yeah, it's a little-
Okay. So this is a solution, ladies and gentlemen. Okay? Now, originally it was soluble. Why? Because it was dissolved. Supersaturated solutions do this. They do a weird thing, which is they're holding more than they're supposed to. Okay? They're holding more than they're supposed to. So when you disturb them, normally when you pop the cork on, boom, they do that. Sometimes you need to give it a little help. Adding a little bit more of what was dissolved in there caused that to happen, ladies and gentlemen. That was a soluble solution, though.
So you just added salt to salt.
I added the same thing that was in there. And when we did, you know, it's kind of like having a bag of groceries that's kind of overflowing at the top, and then they try to put that one more thing on it, and then everything kind of falls. Same basic idea, ladies and gentlemen. Okay? But the point is, when you have a compound, two things are going to happen. Either that compound will dissolve in water, meaning it is soluble, or it will not dissolve in water, meaning it is insoluble. Okay? If it is soluble, we will know that because on this chart it will tell us that it makes a precipitate. And we have showed you how to read this multiple times. Up at the top are the things that will never precipitate, that are always aqueous. Anything with chlorate, anything with nitrate will always be aqueous. In the middle, the things that are normally aqueous unless they happen to be with one of these exceptions. And then down at the bottom, the things that are normally a precipitate, a solid, unless they happen to be with one of the exceptions that would make them aqueous. Okay? We've explained this to you a few times, okay? So, if you look at a compound, ladies and gentlemen, and if that compound shows that it is aqueous, excuse me, something different will happen than if you look at it and it says that it is a precipitate. So, if you are insoluble, insoluble means you will not dissolve, ladies and gentlemen. So these are compounds that will precipitate. Precipitate means it's a solid. It means it will not dissolve in water. It will be like the sand sitting at the bottom. So an example of that, ladies and gentlemen, would be silver chloride. If you take silver chloride and you try to put it in water, guess what? It stays silver chloride. Nothing happens to it. Why? It is a precipitate according to your sheet. If you look at chloride, the second one down in the second set of tables, silver is one of the three things that it will precipitate with. Lead and mercury are the other two. So what that means is if I try to put this into water, or if it is created from a reaction while in water, it will go and it will settle out to the bottom and it will stay this one compound. That's what it will be. The same thing is true, ladies and gentlemen, for lead sulfate. You put lead sulfate into water and it will stay lead sulfate. It will not break apart. Lead sulfate, that is the, again, middle section, the second one from the bottom. Sulfate, SO4, will precipitate with silver, lead, bromine or barium, strontium, and calcium. Since it's with lead, it will be a precipitate. It will not dissolve in water. Calcium chromate will not dissolve in water. It will be a precipitate. Bottom part of that middle table, CrO4 with calcium will be a precipitate. All of these things will be a solid. That means this is how they will appear in water. What you see here is what they would be like in water. Why? Because they don't dissolve. Questions?
Have you said a periodic table, or should we write them down?
Again, we're getting this off of this sheet, determining whether it will be a precipitate or whether it will be a solid. So I don't know how you could write all of the different compounds down because there are many things that could precipitate and many things that could be aqueous. It's a matter of, can you read this sheet? Can you use this when you look at a compound? Okay. Now, there are things, ladies and gentlemen, that will be soluble. So what soluble means are these are things that will be aqueous. That means they will dissolve in water. That's a compound that will break apart. And what actually happens to an aqueous compound is it literally breaks apart into the ions that make it up. It literally breaks apart into the positive and the negative ion that make it up. Okay? So, it breaks into a cation, it breaks into an anion, ladies and gentlemen. So, for example, if you take silver nitrate and put it in water, this is what happens to it. It literally breaks apart into a silver ion and into a nitrate ion, and you are going to be expected to write this out on your test on Friday. If it is aqueous, if it will dissolve in water, you will write it as two separate pieces with charges, both of which are aqueous. So this compound breaks into the positive ion for silver and the negative ion for nitrate, and they are both aqueous. Questions? Lead chlorate does the same thing. It breaks apart into the ions that are making it up. By the way, why is there a 2 in front here?
To make it.
Leap. Because in this compound, there are 2 of these ions. That's why it's in parentheses, and that's why there is a 2 here. There is only 1 of the lead, which is why there is no number out in front here. So we have 1 lead ion here. 2 chlorate ions here. This is still like a balanced equation, ladies and gentlemen. And this is what happens when we take this and put it into water. It breaks apart into the ions. How do I know? Because when I look up on this chart, chlorate, nothing will be a precipitate with it. Everything will be aqueous. Since it's aqueous, that means it breaks apart into the ions that make it up. Questions? Wonderful. Sodium phosphate. According to our chart, phosphate normally will be a precipitate. Normally it would be a solid, unless it happens to be with the cations of group 1, except for lithium. Well, sodium is in group 1 and it's not lithium, so that means that this exception will be aqueous. Meaning, you will end up with 3 sodium ions. Why 3? Because of the 3 here. And 1 phosphate group. Why 1? Because the PO4 is not in parentheses. And by the way, if you forget the charges, you get it wrong. Because it doesn't break up into atoms, it breaks up into ions. Questions? Aluminum sulfate in water. Again, when you look at this sheet, sulfate is in the middle section. Second one from the bottom. The things that it will precipitate with are silver, lead, barium, strontium, and calcium. Aluminum isn't one of those things. Therefore, ladies and gentlemen, this will break apart into 2 aluminum ions. Aluminum is always a +3. And it will break up into 3 sulfate ions. And on the back of your sheet, you will find that sulfate is a -2. So if you've been wondering where these charges come from, they come from either the location on the periodic table or the polyatomic on the back of your sheet. On the back of your periodic table, not this sheet. Questions? Okay, so before we do that, ladies and gentlemen, grab a sheet of paper. Tell me what happens to each of these 4 when you put them into water. First thing you need to do is determine if it will be a precipitate or if it will be aqueous. Once you have determined that, then you can decide what will happen to it in water. Yes, Cynthia. I don't care where you do the work. There's scratch paper up there. Charges are always written after the formula in the upper right-hand corner. So a charge, like a subscript, is always written after and below. A charge is written after and above.
I know, but I don't want us to like change the charges or is that right?
Well, those aren't charges because those are just numbers. You need a positive or a negative with them. And then if they're gonna break apart, you need to put a plus sign in between them. So if they're going to break apart, you have to put a plus sign in between them. So what I just showed you, and Olivia, I'll get there in just a second, please,
Oh, okay.
is this. This ion, aqueous, plus this ion, aqueous, is what will happen to this compound when you put it in water. So if it is going to break apart, you need to show it breaking apart by putting a plus sign in between them. You need to show what charge each ion has, and you need to put AQ after it to tell me that it is dissolved in water or aqueous. Okay? Now, if it did not dissolve, you would put it this way. You would just rewrite the compound exactly as it was over here, and you would put an S after it. So if it's not going to break apart, this is what you are going to do. If it does break apart, this is what you do. You show it being broken apart into the two ions, you put a plus sign in the middle of it, and you put aqueous by it. Okay? So that is what you're either doing one or the other. Either it looks like the ones I just showed you or it looks like these. Okay? So let me go back to that so you can see which compounds you're doing still. There you go. Yes. By the way, by writing water over the arrow, ladies and gentlemen, that means we're putting it into water. We're putting it into water. Now tell me what will happen. Well, that goes back to this. Is it aqueous, meaning that it will break apart, or is it a precipitate, meaning it will not?
Well, so if it's Ca over here, it would be a precipitate?
Well, that's what it says, right? Forms a precipitate with these.
What about SO? Oh,
It's got to be that with these to be a precipitate. So you got to see what the two things are.
so this with this is a precipitate?
Okay, so it means that if you have this OH with almost anything, it's going to be a solid. It's going to be a precipitate. Unless it happens to be with this thing, or it happens to be with a cation of group 1 or 2. What's a cation of group 1 or 2? That is these elements here. So if it happens to be with one of those, now instead of being the precipitate it normally would be, it will be aqueous.
Okay.
Okay?
This is great. Am I supposed to put 4 down here?
No, the 4 from down, the 4 from, where'd you get the 4? No, leave the SO4 together. Do not change the group. The only time you put a number out in front is if the group happens to be in parentheses. And no, polyatomics can be in parentheses if we need 2 or 3 of them or something like that, as we just showed you on the other side. So the one on the bottom, the polyatomic, is in parentheses, and there is a 2 by it.
So that's what I heard. 2.
That's where you would put the 2 in front of the PO4.
That's what I heard. Using the charges and the
Correct.
That's it.
Correct.
Um,
What's yours? I'll get back to you in one second.
So I see the CRO right here.
Yep.
So
All
it
learners
says
are
energy over here, so that would be a.
So that's when this says normally aqueous, unless with these exceptions. So that's the way we read that part of the chart.
Okay, and then, do I put this in parentheses?
Why? I didn't put it in parentheses on mine.
So if only parentheses up there, then.
The only time I'm putting it in parentheses is if I need more than one of those groups to balance out the charge of the first one.
SO4 is with CA, and CA is solid.
Here's the problem.
I did not follow that.
What?
It's
Yeah,
okay.
yeah,
It's
you
usually
should.
they're both.
It's usually when I
I
separate
did use it, but not.
things plus CRO for AQ or.
Oh, I did that.
Oh, yeah.
No, if it is aqueous, what that means is that it is going to break apart and we are going to show it being broken apart into the two pieces that make it up. If it is a solid, we don't do that.
SO4.
So what you meant is that this compound here would be a solid, not a precipitate.
I didn't get it.
Nothing happens.
I'm just freestyling.
So it doesn't break apart.
You got all the wrong.
Why? Because Ca
Freestyling is the best way.
and SO4 form a solid. Correct. In this part of the table. Up here, these are always aqueous no matter what.
So you're not
In this part, they are normally aqueous unless they're with these exceptions. And down here, they're normally a precipitate unless they happen to be with these exceptions.
Honestly.
I thought you said.
So if I have two here and two here, I just cancel them out.
No, you don't. You write them as with the two because now you're showing them as ions.
That's literally my.
They cancel out when they make the formula.
And then that's not
I'll slide to.
I will. We'll give you the answers to all of these.
It's gonna be on the test plate. It's the ionic compounds in water.
Okay, so here we go. Normally, it
Also,
will be a
probably.
solid
I'll let you walk in.
unless it's with.
If it's not like sugar cation ions, do I just leave it?
I know what I do. Yeah, you just gotta look at it. It shows very good. If it's not on there, then it's aqueous.
So it says.
Yeah.
No, why do you have this stuff in your car? It's like seven,
It's on here. And the match
It's
is
checking
this.
C.
Oh.
Is it?
Oh.
Oh.
Yeah.
Yeah, or with Cube in your car too. That will really make you like it.
Still don't get it.
Fumes and it will be like this.
Okay, what don't you get?
Cool.
Well, you got no paper, you're not even trying. You're telling me you don't get it.
He did it.
My name is Alexis.
Okay,
Why is it
so your first compound, CaSO4. Find SO4 on your pink sheet and find Ca.
That's what I heard.
Well, find SO4, because you may not find Ca.
I mean, yeah, I
Find
know what it
SO4.
is, but
So for on this side, right?
Yeah,
it's just-
but again,
and this one.
ladies, gentlemen, children of all ages, anybody else not covered in the opening statement? I asked you a long time ago, when you got this, to put some notes on there. Now, some of you refuse to do it, or at least refuse to look at those notes. Here's what I mean. This section up here, you look at what the second part of your compound is. If the second part of your compound has ClO3 or NO3 in it, there is nothing that I can put it with that will cause it to precipitate. Nothing. So this part of the table up here, we had you put a note, is always aqueous. No matter what, they are always aqueous. Now, this part here, we have some more anions. Some of them are polyatomic, some of them are just elements that are ions. This table here tells us that these things are normally aqueous, normally will dissolve in water, unless they happen to be with these few exceptions. So if your compound is AgC2H3O2, that is no longer aqueous. It is with the exception, it will now be a solid. Clear on that?
Yes.
Yes? Okay. Then the bottom part of the table, the third part, ladies and gentlemen, the reason that it is separated is because now these things, which we always base it off of the anion, the last part of your compound, if it is with most things, it will be a precipitate. It will be a solid. Normally a solid. Unless it is with these exceptions now. The exceptions now make it aqueous. Here, the exceptions made it a solid. Here, the exceptions make it aqueous. And up at the top, there are no exceptions. Okay? They're always aqueous. So, when you look at a compound, and your compound has OH in it, okay, I'm looking here. Now, what is with the OH? Well, let's put K with the OH. Okay, now I need to find where K is on the periodic table. K is right here. That means that it is in group 1 of the periodic table. That means that this compound overall will be aqueous. Now, because it is aqueous, we are going to break it apart into the atoms that make it up when we put it into water. Questions? Now, if I had taken that same OH and put it with aluminum. Now, again, the formula would have to have a 3 here. Why? Aluminum's a +3. OH is a -1. This is how we would write a balanced compound for it. Potassium here was a +1. OH was a -1. That's why I didn't do it, if you're wondering why I didn't do that up there. Okay? Now, here's the OH. It is no longer with the cation of group 1 or 2. Why? Because aluminum, ladies and gentlemen, is over here in group 13. So now it is not with an exception. That means that this will be a solid. Now, these two things, when placed in water, will do something very different. When you put this in water, nothing happens. Why? Because it's a solid. Nothing happens to it. It stays a solid. When this gets put into water, it breaks into potassium ions. I have to put the charge up there because otherwise it's not an ion. An ion is a charged particle. That is what this is. And it will be aqueous. Plus, the OH has a -1 charge right there. And it will be aqueous. So what happens to something that is aqueous in water is it breaks apart. What happens to something that is a solid when put in water? Nothing. It stays exactly the same. Yes.
Can I go to the bathroom?
Sure, go ahead. Questions? Your mouths say nothing, but your eyes tell me a different story for some of you. So again, give you a couple minutes, and then we will go over these, ladies and gentlemen.
Wait, so if it's a solid and doesn't have an S at the beginning, do we just add it?
Slow down. I'm sorry. I didn't follow that. Please ask the question again.
So if we have a solid,
Yeah.
it's a solid.
Yes.
And we just add the S at the end?
Yes, you don't do anything to it. That's my point. If this is a solid, when you put it in water, it's going to stay exactly the same. Nothing is going to happen to it. Okay?
It's not.
So on the test, I'm going to give you these two compounds and ask you to tell me what happens to them when you put them in water. What I expect to see for this one is this. It stays together and it's a solid. What I expect to see for this one is it breaks into the two ions that make it up. And by the way, because these are ionic, there will only be two different things that it breaks up into. Now, there may be more of one or the other. You might have to put a 2 here or a 3 here, something like that, but it's still only breaking up into two things. And that's what I'm asking you to do. Okay? All right? Finish. We'll go over them in about 3 minutes. Okay? If you still have questions, call me over and I will be happy to go through it again with you individually or look at one of yours and go through it with you. Okay? If you want to add the notes that I have added to mine, come on up, take a look at it, add the notes that you need to it. By the way, it's back to a soluble solution because all I did was heated it up. And everything that was in there is now dissolved again in the water. Okay? Everything that is in there is back into the form of ions because it is dissolved. So this note is just how to basically read this. These are always aqueous. No matter what they're with, you don't have to worry about it. They're always going to be this way. Here, they're normally going to be aqueous unless with these exceptions. Then they will be a solid. Down here, they are normally going to be a solid unless they happen to be with these exceptions. Okay, so that's the way we read it. That's the note that I wrote on the side. Be there in 1 second. Yes. Cation means positive ion. That's what metals are. So it's big. Okay, so then, oh, you're right. I'm sorry. I was looking at it wrong. I bet. Yes, you're correct. Sorry. I bet. It's going to be aqueous. It's going to be aqueous. Yes. Yes. Who looks it? Yes. I'll go through it when I put them up on the board. Let's see. Oh, I'm sorry. Yes. I'll put it back to the problems that you're supposed to be working on. Sorry. What do you
Because what is it? That is a negative charge. So you can get the factor. But the matter is, so I don't know for 2 days it's supposed to be so
All right, ladies and gentlemen, let's go over these. Let's make sure you have an idea about them. If you have questions, please stop me. Please ask the questions, okay? But again, it comes back to being able to read this table. The first thing you have to do is decide if the compound is aqueous or if the compound is a precipitate and a solid. So the first thing that we're going to do before we do anything as far as what will happen to them in water is we're going to look each one up and we're going to see if it's a solid or if it is aqueous. So when we look up calcium sulfate, okay, when we look it up, you guys probably can't see that, can you? Okay, we'll go this way. So here's sulfate SO4. Calcium is one of the things that if it is with it, it is going to be a what? It's going to be a solid. What that means, ladies and gentlemen, is that this one is going to be a solid. Anyone have any questions on why that is? Okay, let's go to the next one. The next one is magnesium chromate. Well, here's chromate down over here now. The exceptions that would make it a solid, magnesium is not one of them. Therefore, it's going to fall into this category where it is going to be aqueous. Now we go to the potassium hydroxide, ladies and gentlemen. Down at the bottom here is hydroxide. It is normally a precipitate with most things, unless it happens to be with a cation of group 1 or 2. Well, potassium is in group 1. So therefore, ladies and gentlemen, this is going to be aqueous. Again, questions. Barium phosphate, the last one, ladies and gentlemen. Here is phosphate down at the bottom. It is normally a precipitate unless it happens to be with cations of group 1. And even if it's with them, it would not be aqueous with lithium. Barium is not in group 1, ladies and gentlemen. That means that this will be a solid. So if it's a solid, boom, easy enough. Nothing happens to it. That's all you would have to write down. You're done. The ones that are aqueous, now, magnesium. What's the charge on magnesium based on where it's at on the periodic table? +2. Now, again, charges are positive or negative. I understand by saying 2, you may be meaning +2, but we need to write the positive sign up here. Down here, we go with AQ. Why? Because it's aqueous. Plus, the other thing it's with is CrO4. What is the charge of CrO4? -2. And again, we put aqueous down here. I don't put anything in front here or here because there is no number here, and this CrO4 is not in parentheses. If the CrO4 were in parentheses, I would put a number there. The reason why we don't is the 2 and the -2. We know those cancel out. All right, so KOH, aqueous. That means potassium +1 charge is going to be one of the things that it breaks up into, and hydroxide -1 is going to be the other thing it breaks up into. Okay? Questions? If this had instead been calcium hydroxide, this is also aqueous, ladies and gentlemen. When it breaks apart in water, it will break into calcium +2, aqueous, plus 2OH, -1, aqueous. Where did this 2 come from? It came from the number outside the parentheses. Outside the parentheses. Do not take the 4 in CrO4 and move it into the front. That 4 only goes to the oxygen, does not go to the Cr. So that's the difference. If there's any number in front of a polyatomic, it will be the number that is outside in the parentheses. Questions? Yes.
Wait, so is that the final answer, or did you just add that to show an example of the number in front?
This one I just added just a second ago because I wanted to do one where there was a number down here.
Okay, thank you.
So that was not one of the ones you did. Yes.
The last one.
What's that?
I think it's the last one.
This one or this one? Okay. So again, we go to our table. Here's PO4. Okay. It says that it will normally be a precipitate. Most things. Unless it's with the cations of group 1. What are the cations of group 1? First of all, a cation is a positive ion, ladies and gentlemen. So these metals here, lithium, sodium, potassium, rubidium, cesium, francium, those are the metals and the cations of column 1. They will all have a +1 charge, but they are in column 1 or group 1 of the periodic table. Now, the one thing we have to be careful of is with this one here, It says the cations of group 1 except for lithium. So, let me get that out of the way.
What did it include?
So here's lithium, sodium, potassium, rubidium, cesium, francium. Those are the ones that it will be aqueous with, except for lithium. Even though lithium's in column 1, that will still make it a precipitate. I'm sorry, go ahead, Sophia.
Would it also do it with hydrogen? So that
No.
It can be both.
No. I wouldn't do that to you. I wouldn't give you that with hydrogen. No. Okay. Questions? Yes.
So where did the 3 come from? Because the charge
Where did what 3 come from?
Go back to what you were doing. It's Ba3.
Oops. That is about writing a compound. Barium, Ba,
Which the charge
is a +2. Phosphate, PO4, is a -3. The 3 and the 2 end up switching places to write a good compound.
Okay, I got that.
Okay, good. Questions? Other questions? All right. So, here's where this comes into play, ladies and gentlemen. If you have a reaction such as this, aqueous magnesium chloride is mixed with aqueous silver nitrate and will react in a double replacement reaction. Why? 2 compounds. Mix them together, you are going to create 2 compounds. We covered this in Unit 4. The magnesium and the silver end up switching places. So the magnesium ends up with the NO3 on the product side, and the silver ends up with the chlorine. Otherwise, if they don't switch places, nothing is happening. So there's no reaction if they don't switch places. Now the question is, after they switch places, did something actually happen? And the answer is yes. Why? Because of that S right there. One of the things we look for in a double replacement reaction is what is called a precipitate. This is a precipitate. So we started out by writing our 2 compounds that we begin with. We then predicted what we would create. Okay, you have done this before. This is all what your lab was about at the end of the first trimester. After this, we would take and we would balance our equations, all right? Okay, so after we find a precipitate, we know the reaction occurs. Now we are going to balance our equation. That means that I need to put a 2 in front of the AgNO3 and a 2 in front of the AgCl. Why? Because I had 2 chlorines here. I need 2 chlorines here. I have 2 NO3s here. I need 2 NO3s here. And then I have 2 silvers and 2 silvers. This is a balanced chemical equation. We're not getting into that right now, but are there any questions? Okay. This is the equation, but this really is not the reaction. Okay? Anybody ever hear of spark notes? You guys don't know what spark notes are? Leaf, what are spark notes?
Basically just like notes that like just quick flashcards basically.
Of a what?
Anything you need.
Well, no. Okay? When I was a kid, we had to do book reports. I hated book reports. So every book report I ever wrote was on a book that they made a movie out of. Why? Because I could watch the movie and write a book report about the movie. If, unfortunately, the teacher assigned us a book that there was no movie for, we went to what we called the Cliff Notes. The book is this thick. The Cliff Notes are this thick. The Cliff Notes are a summary of what happened in the book, giving you enough details to basically get by in a conversation about it. I always found that I wanted to go second in a conversation because I agree completely with what Angel said about the main character and her struggles with this topic or that topic, and then I was off the hook for the rest of the conversation because there were 20-some kids in the class. They weren't going to call on you twice, and I wasn't sure that I was going to raise my hand the second time. Okay? And it got me through language arts class when I was a kid. Okay? But the Cliff Notes, the Spark Notes, boil it down to what's important. So let's boil this reaction down to what's important, ladies and gentlemen. Let's boil it down to what's important. So here's the balanced reaction. Okay. But what it actually looks like is this. There is a magnesium ion. Why? Because this is aqueous. So what does this do? This breaks apart. Here's what it breaks apart into. Plus, this is aqueous, which means, guess what? These things are broken apart. Okay? And then we create this, which is a solid. So I can't do anything to that, can I? And then this breaks apart into these two things. So this is what this reaction actually is. Now, we don't write it this way, but this is what it is. Now, if this were a math equation, and I know I hate bringing up the math term in science because we actually give math meaning, and there were an equal sign there, and you have these two equations with an equal sign, and you got some of the same stuff on both sides of the equation, what would you do to that stuff?
You minus it from both sides.
Well, you just cancel it out, right? If the equation said multiply this side by 2 and multiply this side by 2, why? You're doing the same thing to both sides, right? So you get rid of that, correct? Well, let's get rid of the things that don't change here.
Magnesium.
Okay? Magnesium is the exact same on both sides. Guess what? Magnesium ain't doing a dang thing. It's just standing there. We call it a spectator ion. Hey, what's happening? Oh, cool. Look, something's happening over there. I'm not doing anything, but something's happening over there. What's the other one that's a spectator ion? The NO3 group. It's the same on both sides. So let's get rid of them. So guess what? That whole big equation comes down to this. Chlorine and silver react to make silver chloride. That's it. That's what that whole reaction is. That's the summary. That's the summary, ladies and gentlemen. And that is taking a balanced chemical equation to what is called the net ionic. And that's why we have to find a precipitate. If that didn't precipitate, guess what? Everything's a spectator. Nothing happens. It's the same stuff at the beginning. It's the same stuff at the end. There's no reaction. Okay? Sure, go ahead. Okay? So let's take a look at one more and then that'll be it. Again, the skeleton equation. Unit 7 is this exact type of problem on your test. There's 4 of them. 4 of them. Now, we add a little more to it. But you got to start by doing this. Writing down your compound plus your other compound and predicting what you would create. Remember, the aluminum and the lead have to switch spots. At the beginning, these are both aqueous. I got news for you. If these weren't aqueous, there's not going to be a reaction because you already got a solid. Your solid isn't going to break apart. Okay? That's a single replacement reaction, not a double. But when they break apart and switch, aluminum ends up with nitrate that stays aqueous. But the lead gets with sulfate. And now lead with sulfate makes a precipitate. Now we have a reaction. So now we balance it. Okay? Now we balance it. We put the numbers in front that get it to balance. Again, we'll go through and we will review that scoreboard. We will go through and we will review how we count up the atoms on each side. Okay? For now, no. But this is balanced. 3 lead. 3 lead. 3 SO4 groups. 3 SO4 groups. 6 NO3 groups. 3 times 2 gives us 6 of these. 2 times 3 gives us 6 of these. 2 ALs. 2 ALs. Everything is balanced. Now, again, take that balanced equation and make an ionic one. Overall ionic says anything that is aqueous, let's break it apart. This breaks apart. This breaks apart. By the way, why a 6 here?
The 2 and the 3.
The 2 here and the 3 here means there are 6 of these ions. Why the 3 here? The 3 here says there's 3 of these. Okay? Again, we're not worried about that right now. What are you going to create? Well, this is going to break apart. 2 of these, 6 of these. But this, that stays together. Nothing happens to it. Nothing happens to it. Okay? So get rid of the things that aren't doing anything. Aluminum, not doing anything. Nitrate, not doing anything.
So if you have the same amount of element or whatever compound, you can just take it out. On
Well,
each side.
if it's not, you have to get to the point where it's ions. The compound won't appear the same on both sides. Okay? This was the original compound. It isn't the same on the other side. But the two things that this breaks up into, one of them ends up just watching here. One of them ends up in the actual compound here. Do you understand what I mean?
Yeah.
Same thing here. This ends up just watching. It doesn't do anything. It was ions at the beginning. It's still ions at the end. It's not doing anything. But this then reacts with this stuff. Okay? So the reason for this ionic compound and this ionic compound making those products is because an ion from here and an ion from there get together and make a precipitate. That's what happened in your lab when you got something to actually show up on that well plate. When you put those two things together and you got that color change, that solid, that substance there. That's why. You were actually making something new that wasn't there before. And it took part of one compound and part of another compound and put them together. That's what a reaction is. Okay? That's what a reaction is. Now, am I going to test you on this tomorrow? No. No. Are we going to need it later on in Unit 7? Yes. So questions? Now, while I'm not going to test you on all this, you better be able to take this and get to this. That's on your test tomorrow. You better be able to take this and get to this. You better be able to take this and say, nothing happens here, I'm just going to rewrite it. That is what is on your test. I'm just going to begin by saying this compound. I won't put the S by it.
Yeah.
This compound.
We have to do
If
that.
you put it into water, what happens?
So we're just doing the ones in water, not like that?
Correct.
Oh, okay then.
Correct. So it's going to say this without the S here,
Mhm.
put into water. What happens to it? Well, it doesn't break apart. It's a solid.
Wait, is everyone taking the test tomorrow or just the
No.
kids who are leaving?
No, sorry, just those. I should be saying the test on Friday. That's my bad. The test on Friday. Okay. So these, because they are aqueous, are going to break up into the ions that make it up. Okay. Questions? Now, before we wrap up for today, I would like to give you this advice for your test and for any future tests in this unit or in this trimester. When you get my test, do not do problems 1 through 12 or 1 through 9. Look at the test and find the problems that you think you have the best shot at. And do that. Some of you may not finish the test in the 71-minute period. You should, but you may not. So do the ones that are going to put the points in the bank for you that are going to make your test score go up. If you don't know how to get from grams to particles, skip that problem. Go to the empirical formula. Go to the molecular formula. Go to the percent composition. Those are the ones that are worth the most points anyway. Now, if you can't do anything on the test, I'm sorry, you're screwed. Okay? That's the honest to goodness truth. You are. But again, if you feel like you're in that position, you should have been coming and getting help from me. And there is still time. Okay? But if you look at the packet and there's a problem in the packet that you can't do now, that's a problem because those are the things that are going to be on the test. Tomorrow, I am going to give you practice on the 3 major types of problems on the test. Empirical formula, molecular formula, and percent composition. But again, if you're good at those, do those first. Give yourself some confidence, get some points in the bank. Then do the ones you struggle with. And here's what I will tell you. If you leave it blank, it's worth nothing. If you try to convert to moles and use a wrong number, maybe you'll get a point for still trying to go to moles. Maybe you'll get a point for putting the right unit and the right sig figs down, but maybe you got the wrong answer when you multiply. Try to get every point you can. But again, the problems that are confusing you, the problems that are giving you the most trouble, save those for the end. Why? If you're going to struggle on them as time is running out. Don't struggle on them at the start and then be like, I didn't get a chance to get to the ones I knew. Do the ones you know. Do the ones you know. Questions, ladies and gentlemen?